So today we're doing mission 2A, which is graphing linear equations. We're going to look at tables and graphs today. So it says you are going bowling with your friend. Bowling costs $3 per person, or per game, sorry, and shoe rental is $2. Your friend has their own pair of shoes, but you do not. Write an equation for the cost of each person. So, key words here, that your friend has their own shoes, but you do not. So, you need to buy shoes your friend does not. So, down here, it says C is going to represent the cost, and G represents the number of games that we bowl. So, the cost for your friend is going to be what? Well, your friend has to pay for bowling, and each game costs $3. But we don't know how many games that we're playing, so we're going to use G to represent the number of games. So $3 times however many games we play. So if we play 2 games, 3 times 2 would be $6. But your cost, you're still paying for bowling, so you're paying $3 times the number of games, but you also have to pay for shoes, and the shoe rental costs $2. So you're going to pay $3 for every game, plus you're also going to pay $2 for shoes. Now you're only paying for shoes one time, so we don't need to multiply that by however many games we're playing, because you don't need to rent new shoes every game. You can just wear the same ones the whole time. So here are our 2 equations to represent your friend's cost for bowling and your cost for bowling. So let's take this information and graph it. We have 2 tables here, one for you and one for your friend. And we're going to graph the number of games, however many games we bowl, and to figure out what's the cost on this side. This is our x-axis and our y-axis. So, how many games could we bowl? We could bowl no games, right? We could bowl 0 games. We could bowl 1 game, 2 games, 3 games, 4 games. We could go on. But for each of us, we're going to graph up to, oops, I skipped 3. We're going to graph 4 games. 5 including 0. So, in the middle column of our table, we have our equation. $3 times every game we play. So first, we're going to play 1 game, so instead of a G, we're going to use the number 0. So 3 times 0 is 0, which makes sense. If you don't bowl any games, you don't have to pay for anything. So if we bowl 0 games, it costs us $0. So that would be right there, that much money. Then, if we continue, bowling 1 game, $3 times G, the number of games, which is 1. 3 times 1 is 3. So if we bowl 1 game, we have to pay $1, $2, $3. If we bowl 2 games, our equation up here says $3 times the number of games, which is 2. 3 times 2 is 6. So if we bowl 2 games, 1, 2, it'll cost us $6. I'm going to go out to 5 here and continue to number my lines. 9, 10, 11, 12, 13. We'll go to 16. Hopefully that'll be far enough. We can always add more numbers later. Now if we bowl 3 games, $3 times number of games, 3 times 3 is 9. So if we bowl 3 games, it'll cost us $9. So at 3, we'll go up to 9. And then 4 games, so we have $3 times our number of games, which is 4. All I did here is, instead of the G, we're putting in what is G, how many games we're playing, 4. 3 times 4 is 12. So when I'm graphing my information, I'm not graphing this information in the middle, that's just helping us get to our answer. So this number 412 is really 4, 12, written as an ordered pair. 4 games would cost us $12. So we could draw a line through here to represent how much we pay for each game. If this were to continue, it would go on in that direction. So this is for your friend. But what about you? Let's take a look at the equation for you. Your equation is $3 times the number of games. So first our number of games is 0, but then we have to add $2 for our shoes. 3 times 0 is 0. So always do order of operations here, PEMDAS. always multiply first. So we have $0 plus 2, which is $2. If we're going to go into the bowling alley and rent some shoes, it'll cost us $2, even if we don't start playing yet. Then, if we play one bowling game, $3 times that one game, plus you still pay for the shoes. 3 times 1 is 3, plus 2 more is 5. So this time, all we have to do, we times 1, 3 times 1 is 3, 3 plus 2 is 5. So one game, we're up at $5. If we play 2 games, $3 times 2 games, plus 2 more, 3 times 2 is 6, 6 plus 2 more, oops, should be 8, $8. So at 2 games, we're up to 8. At 3 games, $3 times 3 games, 3 times 3 is 9. 9 plus 2 is 11, so 3 games go up to 11. And we'll do one more, and make our table go a little bit longer if we need to. $3 times, instead of a G, we're plugging in a 4. 3 times 4 is 12. 12 plus 2 is 14. So for 4 games, it would cost us $14. And you could draw your line through here as well. So here's the equation for U. So we've graphed both equations. If we flip to the back side, I have them graphed here again. It just says what is different and what is the same. Well, the same, you can see that the angles of the lines, maybe some of you know that they're parallel, or they go at the same rate, meaning we have to pay $3 per game each time. So that's the same. For every game, every one more game that we play, we go up $3. What's different? That one of us is paying for shoes, so the starting point is different. On the y-axis, you have to start $2 higher than your friend because you have to pay for shoes. So if we look at our other 2 questions, how much will you each pay for 5 games? So if we go out to 5 games here, we could follow this up to you and your friend, looking to see where do they cross the lines. So this first one for 5 games, your friend is right there and you are right there, looking for where does it cross a nice corner of our graph. We'll follow this to the left to figure out how much money right there does that person have to pay, and how much money right there does that person have to pay. Oops, I think I made a mistake. One of these is a little off. Let's double check this. The lines aren't perfect here. This one should be here, and this one should be right there. So if we count up from the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So your friend would have to pay $15, but you only have to pay, or you have to pay more, sorry, $17. So this is your friend, and that's you. And then how much would you each pay for 6 games? Well, you could use the graph and follow it up again, or you know each game costs $3 more, so $3 more for each of you would cost your friend $18 and you $20. So you could use your original equations. C equals 3G plus 2. Or look at your graph. There's 2 ways to figure out this information. All right, let's take a look at our last equation. Very different. It just gives us an equation that we need to graph. So here we have our XY table. We always put our equation in the middle. Y equals 2x plus 1. So we're trying to get y, so our answer for y is going to really go up here. So we're just plugging in our numbers for x. So we are using the numbers -2, -1, 0, 1, and 2. So every time we see an x, I'm instead going to plug in whatever number it says for x. So we have 2, since this is touching, it's multiplied, 2 times x, but x is first, a -2, and then we need to add 1. So 2 times -2 is -4, but plus 1 more, there's more negatives than positives still, it should be a -3. If I owe you $4 but give you 1, I now only owe you $3. Next, same thing, 2 times x, but x is this time a -1, and then add 1. 2 times -1 is -2, and -2 plus 1, still more negatives, just one more negative. Then plugging in for x a 0, remember you're taking the x out and replacing it with what does x represent, or what is x? X is 0, and then plus 1. 2 times 0 is 0. 0 plus 1 is 1. Next, plugging in a 1 for x up here. 2 times 1 plus 1. Always do your multiplying first. Remember, we're doing order of operations. Multiply and divide come first. 2 times 1 is 2. 2 plus 1 more is 3. And then our last number, plugging in a 2. 2 times 2 is 4. Plus 1 more is 5. So we have our x and y coordinates. Each of these represents a point. X is -2, y is -3, and then for example this one is -1, -1. Here we have 0, 1. Here we have 1, 3, and 2, 5. X, y. If you don't need to write them out and you can see it just from the table, that works too. So -3. So let's plot our points. First, on our x-axis, -2, and then -3 is down 3. Then at -1, which is right here, it's hard to see, we are down 1, so -1. Then at 0, we didn't go left and right, we just went up 1. Then at +1, x to the right 1, then up 3. As you can see, these are forming a nice straight line. And last, at 2, we're up 5. So if you want, you can draw a nice straight line through there. If your points don't make a straight line, we made a mistake somewhere. So it says use the graph or the table to find y when x is 3. Well, here's our x-axis. We can see 3 is right here. If we're going to follow that up to the line, where do we meet? Well, it crosses or hits right there. Y is at 7. So y would be 7. You could also plug in x is 3. 2 times 3 is 6. Plus 1 more is 7. That would have been the next point if we were to graph it. -7 over here, though, isn't going to hit our line. Our line doesn't fit on the graph. There's not enough space. So this one we'll need to use the equation. Our equation is y equals 2x plus 1. We want to know when x is a -7. So 2 times -7 plus 1. Well, 2 times 7 is 14, but it's negative, so -14. -14 plus 1, there's more negatives, -13. So y is a -13.